This is sort of the crux of where I wanted to get up to actually, because we looked at these operations, and I guess, operations in and of themselves, no one, gets super excited about operations or anything like that. But what complex numbers does, it opens up this now opportunity to look at the original problem that we started with. The original problem that we started with was that if I gave you an equation like this, z squared is equal to negative 25, for example, right? Back in advancing extension 1, we would just say, look, there's no solutions. You've probably made a mistake. Nothing we can do with that, right? But now, can we do a bit more than that? Can we actually find the solutions to this? They won't be real solutions, but can we find solutions to this? Or are we still in the same position as we were before? Yeah, well, what would the imaginary solutions be, Alyssa?
Well, it would be the square root of negative 25.
Yeah.
Plus minus, well.
Plus or minus the square root of negative 25? Is that what you're saying? Yeah. And what is the square root of negative 25?
An imaginary number.
It is, yeah. And remember, so I said that we can look at this. If I just go back to the square root of negative 25, just for a second, I said that we can approach this in two ways. We could either say that we can break it up as a surd, right? So we could say, for example, that this is just the square root of negative 1 times the square root of 5. And the square root of negative 1 we know can be written as I, right? So that's I root 5. And so we could say that this is equal to the positive and negative I root 5, right? So these are in fact now our imaginary, sorry, not just root 5, just 5 there. That looked a bit better. The square root of 25 there, that should be. Sorry, thanks for that. Fix that up. Cool. So let me recap that again. So the square root of negative 25 can be written as the square root of negative 1 times the square root of 25, which we know the square root of 25 is just 5, so that'd be just 5i, for example, right? And then we can apply that over here. So here's where we can break it up as a surd, but again, there's different ways to think about this. We can also write the square root of negative 25. We can skip all these steps and we can just go straight to 5i because some people are uncomfortable with writing the square root of negative 1 in this particular way. Okay, so that's just something to keep in mind. But if this helps you visualize and helps you approach the problems more comfortably, then feel free to do that. I'm okay with that personally. But let me go back to this question of solving quadratic equations. Back in advancing extension 1, you have a few different methods of solving quadratic equations. What are a few of those? What's the first one that you guys actually default to? I'm interested to hear. What's your natural approach there? You see a quadratic equation, what's your first approach that you guys try? Factorize, yeah? And then solve for the brackets, yeah? So if it's like a trinomial or something like that, you can factorize it. We can actually factorize with these complex equations as well. So you can factorize or rearrange. Right, that's one thing you can do. What other approaches do we have here with quadratic equations? Quadratic formula, that's the favorite one when people first learn it. It's just like a quick and easy way to substitute values in. Don't have to worry about factorizing, don't have to worry about the non-monic kind of cases. It's all nice and good. There's actually one more. It's probably not the most common way of solving a quadratic equation. In fact, it's probably the least preferred way, to be honest with you. Oh, I didn't even think about that actually. Graphing them, yes, you can do that. I don't know if you could do it with these ones. You probably, I don't know, yeah, you'd have to be sketching in the imaginary. And yeah. So that would be a little bit tricky. There might be a way to do it. I'm not aware of it as far as I'm concerned. The last way is actually also how you prove the quadratic formula. If you ever derive the quadratic formula, if it's a very long, extensive proof, but how you start it, it actually requires this skill to derive the quadratic equation. You actually also do it when you're looking at the forms of circles and you're trying to find its center and radius. If you remember that, you have some powers there, to the powers of 2, and you have to, am I getting any closer? No. It begins with C, and we have to, it's something the something. Completing the square was the last one I was looking for. There it is, on the tip of your tongue, I'm sure. Sorry? Oh, you said it as I said it? Yeah, that's what they all say, isn't it? Completing the square. It's the least preferred way because it's a lot of algebra, and why would you do it when you can use quadratic formula? But just like with the case of the circles, right? We actually need to use that process sometimes to engage with this. And the same thing here, sometimes we may need to complete the square over the other options, right? So let's look at an example. So part 1, this is your first example. Z squared plus 10 is equal to 0. Now, with z squared plus 10 is equal to 0, it's very similar to this one. And the first almost default method is that you can just rearrange and you can actually factorize this. How would you do this? Well, you could do this in a similar way to this one. What would you need to do? You just need to rearrange so you get z squared is equal to negative 10. And yeah, 10 doesn't have a square root as an integer, but we could just write it as z is equal to, what could we write that solution as? If we were thinking about something like this over here. Yeah, that's it. So the positive and negative case is square root of 10i. That's how you could rearrange it and make z the subject there, and then take the square root of both sides there. You could actually also, if you're particularly observant, you could actually also go backwards from taking the sum of the squares, right? Because actually, if you think about it, what are your x and y values over here? Your x and y values are, what, z and 10, right? So you could actually factorize this as z plus 10, z plus the square root of 10i, z minus the square root of 10i is equal to 0. And you would actually still get the same solutions. Using the sum of two squares, you could get back to this. Yeah. So again, use the method that you prefer. I suppose I found this one a bit easier, but it's helpful to know this identity here as well, okay? That you have both options there if you wanted to factorize it, if that's what you're more used to seeing.